Alright, good afternoon class. Okay. Alright, so for today we will continue with the simple linear regression. Okay, last or previous topic is the hypothesis testing, and then today we will do the simple linear regression. Okay, or regression analysis. Right? So under the prediction model or under the estimation model, okay, or statistical model, we have one of the most famous method or statistical model is a regression analysis. Okay, so this slide is already uploaded on my times. You can check and download. Okay, all right. Okay, so the first one. Okay, so the first one of the statistical method. Okay, this one simple linear regression or multiple linear regression you can use for your case study, but of course for your level we use the multiple linear regression. Okay, so regression analysis is very important. Why? Most of the statistical procedure we will use the statistical regression or regression analysis. For example, the agriculture, economics, okay, business, medical, they are using the regression. Okay, all right. So for today only the simple linear regression, and next week we will see the multiple linear regression. Okay, all right. So the learning objective for this one is to describe the linear regression model. Okay, the second one is to state the regression modeling step. Okay, and then the third one is to explain the ordinary least square. Okay, compute the regression coefficient, understand and check the model assumption. Okay, predict the response variables. Okay, all right. So for this one, for this regression analysis, okay. So regression analysis is the type of the probabilistic model. Okay, so under the probabilistic model we have regression model. We also have the correlation model, and then we also have the other models. Okay, so basically before we proceed with the regression analysis, we do the correlation analysis first. Okay, so what is the correlation analysis? We want to study the relationship between the two variables. We want to measure the association between two variables. For example, like you are conducting a study, okay, the student CGPA, okay, based on the time or hour of study, right? Okay, so how time of our study affect the student CGPA? That is what we call as a study the relationship and the measure of the association between two variables. Okay, all right. So basically regression analysis also is the statistical procedure for us to study the relationship between two or more independent variable and also the dependent variables. Okay. Right. Okay, so after we do the correlation model, so we can proceed with the regression model. Okay. All right. Okay. All right. So regression model is a simple linear regression. Okay. Relationship between one dependent variable and explanatory variables. Okay. All right. So to study the relationship between one dependent variables. Okay. It is always one dependent variable with the one independent variable and multiple independent variables. Okay, so use equation to set up the relationship. Okay, so we have the numerical dependent variable or response variables, and then one or more numerical or categorical independent variables. Okay, so to set up the regression analysis, because we want to study the relationship between this one, we must make sure what type of data consists based on the dependent variables, and then we want to check what is the type of measurement data under the explanatory variables. Okay, all right. So use mainly for the prediction and also the estimation. Okay, so after you get the regression model, you can predict what happened in the 10 years in the future. Okay, 20 years in the future. What is this? What is that? Okay, because based on this model, we can predict what happened to the dependent variable if there are any changes in terms of X variables. Okay. All right. So regression modeling step here. Okay. The most important part is we need to know the type Okay, the type of the regression model, we have two types. Okay, the first one is the simple linear regression. Okay, we focus more on the linear regression. Okay, simple linear regression will be whereby this one is only involve 1 IV plus 1 DV. This is the simple linear regression. And then we have the second type of the regression, okay, whereby the second type of regression we have 2 or more independent variable and 1 dependent variables. Okay, the dependent variable is always 1. Okay, this is the difference between the the simple and the multiple linear regression. Okay, for the simple linear regression, the model is like this. Y equal to okay, this is the linear regression model. Okay, all right. So we go with the linear regression model, okay, whereby the simple linear regression is only involve 1 dependent and also the one independent and also 1 dependent. Okay. All right. So the first one, what is the concept of 1 dependent variable and 1 independent variables? Okay. Let's say 1 dependent variable is your, let's say you want to study on your BMI, and then what else? Calories intake, right? Okay, calories intake and also the BMI. So the BMI is a dependent, calories intake will be independent. Okay, you want to study the calories intake, how the calories intake will affect your BMI. So you will only involve 1 independent variable and also the BMI is a 1 dependent variables. Okay, but for the multiple linear regression, what will we do? We either still the BMI as a dependent variable. What will be the independent variable? Maybe the calories intake, okay, or hours of exercise, for example. Okay, so it will involve with the 2 or more. It can be 2 or more. All right, so this one is a multiple linear regression. Okay, so main function for this one, we want to study how the calorie intake and also hour of exercise will affect the changes of BMI. Okay, how does they have a correlation between these 2 variables with this one? Okay, basically to study the relationship between these 2. Okay, right. So this one is the IV, this one is a DV. Okay. Right, so this one is a basic, all right? So of course, in the simple linear regression, we will involve the calculation. Okay, we will involve the calculation, okay? Let's say for the linear equation, we always have the equation like y is equal to mx plus b. This one is for the linear equation. What is y? What is y? The value in y. Okay, m is the gradient. Okay, b is the y-intercept. Okay, so what is the definition of y-intercept? Y-intercept happen when the x is equal to 0. Okay, so basically for the linear regression, it is based on the linear equation. Y is equal to mx plus b. Okay. Alright, so this one is the linear regression model. Okay, so you need to include in your case study the model. Okay, the model for the linear you should include in your study. Alright, okay, so for this one, yi is equal to b0 plus b1 x1 plus error term. Okay, so for this one, this is referring to the population. Okay, population model for the regression analysis, whereby yi is the response variables. Okay, yi is a response variable whereby b0 is equal to y-intercept and then b1 x1 and then plus error term. Okay? Alright, because why error term happen? Because we are doing the probabilistic model. Okay, so error will be in the model. Alright, so b0 is a y-intercept. This one is a independent variable. Dependent variable. This one is the first independent variable. But since this one is the simple linear regression, so they might have only one independent variable, and then this one is a error term. Okay, so somehow they name it as a, for the independent variable, they name it as a explanatory variable and also predictor. Okay, there are three other names for the independent variable. Okay, please include, if you use the simple linear regression, please include in the model the simple linear model. Okay, if you use the multiple linear regression, please include the multiple linear regression model. Okay, and then you need to what we call, you need to label all the notation there. Okay, alright. Okay, the second one. Okay, the second one is the population. Alright, and then we take the sample from the population and then we construct a regression model. Okay, we call it as a estimated model. Okay, estimated model is equal to yi is equal to b0 plus b hat 1 plus error. Okay, alright. So later we will calculate this coefficient and then we need to calculate this coefficient. Okay, the value of b0 and also the value of b1. Okay, right. So the first one is always the model until we use the second one. Okay, this one is okay lah, you just see this one. Okay, the third one, okay, under the regression model, okay, the second step for the simple linear regression is we need to calculate the value of the coefficient. Okay, we need to calculate the value of the coefficient. Okay, so how we're going to calculate the value of coefficient and what coefficient value we need? This one, b0 and also the b1 hat. We need to calculate from the sample that we have. Okay, how to calculate? We have the specific formula, and the name for the calculation is, we call it as a ordinary least square method. Okay, ordinary least square method. Okay, alright, or we call it as a least square method. Okay, for estimation of the parameters. Okay, right. So this one we will focus more on the model and then in the calculation. Okay, so we need to estimate these two values, okay? This value and also this value. What is the method we use? Ordinary least square method. Okay, we will use the ordinary least square method. Okay, alright, so we'll see the calculation first. Alright, this one is the least square. Okay, least square method. Alright, so this is the calculation. Okay, this is the calculation. Alright, derivation of the parameters. Okay, so for the B node, okay, B node here, this one will be the B node is equal to y bar minus with the B1 x bar. Okay, This is the formula. So you should know the derivation. Derivation, we leave it to the mathematician, okay? So the most important part is you just apply this formula. Okay, you just apply this formula to get the value for the B naught, okay? B naught is equal to Y bar minus with the B1 hat, B1, and then this one is the X bar. Okay, alright, so basically this is a derivation for the simple linear regression. Okay, alright, so the B naught is what? B naught is referring to the y-intercept. Okay, so y-intercept is only happen when x is equal to 0. Okay, alright, so this one is for the B1. Okay, B1 here. Okay, you can refer to the B1. B1 is equal to Sx okay, this is the formula for the B1. Okay, actually we have two types of formula to calculate the B1. Okay, this is the first formula, like the standard deviation, and then we also have the another formula. Okay, alright. We can use this formula also for the B1. Okay, alright. So basically we need to get these two values first. Okay. For the simple linear regression, we need to get these two values first, then we can do the prediction, and then we can do the estimation. Okay? Get this value first, these two values. Right, so how to make sure that you more understand on this simple linear regression is, we do the example. Okay? You see the example here, right? Okay. Alright, here, parameter estimation. Okay, alright. So obstetric, what is the relationship between the mother estrol level and the birth weight? Okay, using the following data. Okay, so basically we have the data. Okay, and then for the simple linear regression, we only involve one independent variable, and then we have also one dependent variable. Okay, so for the regression, it is very important to correctly identify which one is the dependent variable and then which one is the independent variable. So for this one, you check this study. Okay, check this study, what is the relationship between the mother estrol level. So we have the first variable is a mother estrol level, and the second one is the birth weight. Okay, but then we don't know which one is the independent, which one is the dependent variables. Okay, so basically, mother estrol level will be independent variables, okay, because it does affect the birth weight. Okay, and then for the X is a mother estrol level, and the birth weight will be dependent variables. Okay, mother estrol level can be the birth weight, right? Okay, so mother estrol level will be the X. Okay, X or independent variables, and then the birth weight will be the dependent variable or Y. Okay, alright, the birth weight will be the dependent variable or also Y. Okay, and then you get the data. So 1, 2, 3, 4, 5. We have only n is equal to 5 data, and then the birth weight is a 1, 1, 2, 2, 4. Okay, if you have this data, okay, this data also can be used for the correlation. Okay, you check first, does the mother estrol level affect the birth weight? Okay, if your correlation gives you 0.8, means that this variable is very, very significant to the baby birth weight. Okay, alright. Okay, so how about if you didn't get the desired value of correlation here? You want to consider the birth weight in your study, but then the birth weight does not have a correlation, a relationship with the mother extra level. So how? Can we include in our model? Can we include or not? Basically, theoretically, we cannot include, right? Because there is a weak correlation between these two variables. But then in practice, normally students will proceed of considering that these two variables, even though the value of correlation is very low. Okay? Alright, okay. So for this one, okay, you need to check with the correlation first. Okay, if the correlation is okay, then you can proceed with the simple linear regression. Why is a simple linear regression? Because only involve one independent variable only here. Okay, so we have extra level 1, 2, 3, 4, 5, and also we have the birth weight. Okay, this is the sample data. Okay, this is the scatter plot, right? This is the scatter plot. Okay. All right, so to estimate this estimation model, okay, we need to use the method of ordinary least square, okay, whereby the first step is you need to do the xi, yi. What is x? X is for the independent variables, and then yi is for the dependent variables, okay, and then we need to find the xi square, yi square, and then x multiplied by y. You still remember on how the frequency distribution table? Okay, midpoint multiplied by the frequency, multiplied by this and this to find the sample variance and so on, right? Okay, so for this one, this is the same or similar with the previous one, okay, whereby you need to find the xi square, yi square, and then xy, okay, because all this one we need to use in our method, okay? All right, so after you get the xi, okay, you got the square of the x and then square of the y, and then x multiplied by y, you get all this one, in this one. Okay, this is the summation for the first column. First column is a 15, another column is 10, this is summation, and all of these are the summation. Okay, why it is important? Because we want to include in this formula. Okay, yi is equal to this. We want to estimate this coefficient. Okay, whereby this one, the B1 is equal to summation of xy minus summation of ex, summation of y, and then divided by n, divided by what else? Summation of x square minus summation of x, the whole thing is square divided by n. Okay, very long calculation here. Okay, so all of these, you need to complete this table first. Okay, then you can proceed with this formula. Okay, only for the B1. Only for the B1 parameters is a long calculation. Okay, summation of xy minus with the summation of x multiplied by summation of y, okay, divided by the number of sample. Okay, and then divide again. Okay, divide again with the summation of x square. Okay, minus with the summation of x divided by n. So, summation of x square are not same with the summation of x, the whole thing is square, just because of this bracket. Okay, alright, so why it is important for us to correctly identify which one is independent and which one is dependent? Because in the formula is only use x. Okay, if you wrongly choose the dependent and independent, it will affect your calculation. Okay, all right, because of the x only will be used for the denominator. Okay, so after that you can get the value. Okay, all right, any question for this example? Any question for this calculation? Yes. No. No formula. Okay? Please remember this formula. Memorize and understand this formula. Okay? Tomorrow we will see the simple linear regression in R. R will help you to calculate all this. Okay? Alright, so summation of xy you can get from here. 37. Summation of xy is 37. Summation of x is equal to 15. Summation of y is equal to 10, divided by the number of sample is equal to 5. Okay? 1, 2, 3, 4, 5. Okay. Alright, so divided by summation of x square. Okay, how to get summation of x square? 55 and so on. Okay. Alright, so you will get the value of the B1 is equal to 0.70. Okay, this method we call it as a ordinary least square method. Okay, least square method to estimate or to calculate the parameter in the regression. Okay, alright. Okay, so after you get the B1, okay, you get this value, okay. After you get this value of B1 here, you need to calculate the B0. Okay, what is the formula for B0? B0 is equal to Y bar minus with the B1 X bar. Okay, so the value for the B0 is depending on the value of you get from the B1. Okay, because you have the B1 here. This one, you have the B1 and then this value is here. Okay, if you didn't get 0.70, it will affect all the calculation. Careful yeah here. Okay, so the B0 is equal to Y bar. So how to get the Y bar? How to get the Y bar? Y bar is equal to summation of Y divided by N. Okay, summation of Y here is equal to 10 divided by N. What is N here? 5. So that is why you get 2. Minus, okay, minus with the 0.70 because this one is a B1 and then X bar. X bar is equal to Xi 15 divided by 5. So you get 3 here. So altogether the B0 is equal to negative 0, 1, 0. Okay. So Yi is equal to B0 plus B1 X1 plus error term. Okay, error term. Alright, so Yi is equal to Y. Okay, what is B0 here? B0 is equal to negative 1.10 plus, what is B1? 0.70 X1 plus the EI. Okay, that is a regression model. Okay. Alright, so how are you going to interpret all this value? Okay. How are you going to interpret all this value? Okay, the first one, we can interpret based on the slope. Okay, based on the slope. Alright, so based on the slope of B1. Okay, so the birth weight Y is expected to increase, okay, by 0.7 of a unit for each 1 unit increase in X. Okay, alright, so birth weight Y is expected to increase by 0.7 okay, unit for each 1 unit increase in the X. Okay, and then X, there is a astro level, mother astro level. Okay, and then the second one, our interpretation is based on the B0. Okay, B0 is for the Y-intercept, right? Okay, so for the Y-intercept, average birth Y is a negative 0.10 unit when the astro level is 0. Okay, how to interpret this one? Average birth weight is a negative 0.10 when the astro level X is 0. So you just replace with the 0. Okay. Alright, so since the B0 is equal to negative 0.10 plus 0.70x plus EI, right? So your study based on the Y-intercept. So Y-intercept is only happen when X is equal to 0. So you replace X equal to 0 here. Okay? So Y is equal to negative 1.0. Okay? Alright, so Y is equal to negative 1.10. How this one is difficult to explain? Because we cannot have a negative weight, right? Weight, if you against the nature, weight cannot be negative. It is always a positive value. So that's why something or maybe the data and so on. Okay, difficult to explain because the weight is always positive value. Okay. The distance also is always in the positive value. You cannot have a negative distance. Even though you walk like this backward, right? You cannot have the distance in the negative way, always in a positive. Okay? Alright, so this one is related to the simple linear regression. Basically, we want to study. Alright, so the question will ask you, what happened, okay, based on this model, right? So what happened if x is changed to the 3.2 something? So what happened to y? So you just replace x with the 3.2. So that is why actually we can do a prediction, and then we also can do the estimation based on the regression model. Okay? Alright, so for the simple linear regression, it is possible for us to manually calculate by using the formula. But then for the multiple linear regression, you need to use the statistical programming to complete all the coefficient estimate. Okay, coefficient parameter estimate. Okay, this one you can use the manual calculation. Okay, after that cannot, because the multiple linear regression, it is involve the matrices. Okay, how about you have 100 rows? Is it possible for you to calculate the matrices? So that is why the R programming is bring forward lah. Okay, for us to make our life easier. Okay, alright. So we go with the second example. Okay, second example for this one. Okay, for the simple linear regression. You are a vet epidemiologist, okay, for the country cooperative, you gather the following data. Okay? Alright, so, in your case study, in your objective, you want to study the relationship between the food intake and the milk yield, okay? Milk yield by the cows, okay? How the food intake does affect the milk produce, okay? How the food intake affect the production of the milk and so on. Okay, this is like the objective. You want to study the relationship between these two variables. So you are conducting a experiment, and then you analyze by using the statistical regression. Okay, you analyze by using the statistical regression. But what is the type of regression you use? It's a simple linear regression. Why it is simple linear regression? Because it is only involve one independent variables. Okay, one independent variable, simple linear regression. Dependent variable is always one. Okay, but you need to check. You need to check what is your type of dependent variables. Either this one is a quantitative, either that one is a continuous, either that one is a ratio, either that one is a binary outcome. You need to check, because depending on the type of dependent variable, it will lead you to another type of regression need to be used. Okay, and then also the regression is a method for the parametric test. Okay, so any data, it must come from the normal population. Okay, if you proceed from the sample which is not come from the normal distribution, okay, it will affect your result. Okay, so before you use this one, check the normality of the data. Okay, all right. So we can proceed with the second example for this one, because tomorrow we will do the R for the simple linear regression. Okay, all right. Given that you have one X and then you have Y, right? So you see that this data. Okay, you see this data and then you see the objective. They ask you what is the relationship between the cows, food intake, and also the milk yield. Okay, so the food intake will be the independent variables, okay, because that one we can change. And then how this one will affect the meat produced by the cow. Okay? Okay. Right, this is a scatter plot. Okay, they just plotting here. You can even plotting with R is better. Okay? Plotting with R is even better. Alright, so we have also the same question. What we need to do is to compute. Okay, to compute and to calculate all the value for the B0 and also the B1. Okay, what is the method? Using the least square method. Okay, same formula. Okay, same formula for the B1, same formula for the B0 there. Right, okay? Alright, so you get the XI. So for this one, XI will be the food. Okay, this one is X, this one is Y. Okay? Alright, so this one is Xi, this one is Yi, and then we have the Xi square each of the observation in the x variable you need to square, and then yi square each of the observation in yi square you need to do the square there, okay, and then xi multiply by the yi, okay, xi multiply by the yi, okay. Alright, so you get all this value, okay, you get all these values similar with the previous example, and then you need to plug in all the value into the formula, okay. Alright, you use this formula, okay, use this formula, and then you get 0.65, okay, 0.65 for the B1, and then find the B naught there, okay, find the B naught, and then you get the B naught is equal to 0.80, okay. Same step of the calculation, only they change the data. Okay, they change the data, and then, okay, they change the data, and also they change the number of sample. Okay, but then same the calculation, right? Okay, so what is our interpretation? Okay, interpretation is can be based from the slope B1. Okay, so the y is expected to increase by 0.65, okay, by 0.65, because here 65 unit when each of the 1 unit increase in the food intake, okay, means that the y is affected by the change in x. That is the simple words to describe this interpretation, okay. Alright, so the B naught is equal to y-intercept is equal to x is equal to 0. So the average y is expected to be 0.8 when the food intake is when the food intake is equal to 0. So you can do the prediction. You can change all the variable here depending on your case study. Okay, you can change all the value here depending on your case study. Okay, all right. So that's all for today. Okay, so basically, the simple linear regression, okay, or regression analysis is the statistical analysis that you can use for your case study. But I don't encourage you to only use the simple linear regression. We proceed with the multiple linear regression because you want to see more of the calculation, and then more of the interaction, more of the relationship between multiple independent variables. Okay, you can use the MLR, multiple linear regression, okay, to check the variable between the independent and also dependent variables, okay. But before you go with the statistical regression, you need to check the correlation first. Similar, check the correlation, all right, and then before you proceed with the multiple linear regression or simple linear regression, check the measurement data for the dependent. Okay, you need to check either this one is a quantitative or binary. Okay, if the y is a quantitative, proceed with the multiple linear regression. Is binary 0, 1, 0, 1, 0, 1, you can proceed with the binary logistic regression. But then it is depending on the y input. Okay, all right, this is the first one. The second one, simple linear regression is only involved with the one independent variable and one dependent variables. Okay. Alright, so one dependent variable and one dependent variable is here. Okay? Alright, after we come up with this model, okay, this we call it as a regression model. So we need to calculate the value here. Value of B0 and value of B1. Okay, so how to calculate? By using the least square estimation method. Okay, so after you calculate all this value, then you can do the interpretation and also the prediction. How you going to predict in the future for 10 years and so on, okay, based on the changes in X. Okay, we expect that any changes, 1 unit changes in X will affect the changes in Y. Okay, all right, so for tomorrow, we will proceed with the R, okay, R for this one. Okay, all right, so class, I will open the one folder for the submission, okay, for the submission of your video on my times, okay, maybe by today. So by today you can see, and if there is folder, you can submit your lab assignment. Okay, for those who are still editing your video, please make sure that your video show that you are running the R code. Okay, you didn't have to have a slide and so on. Okay, and then the submission, should you submit based on the video or link, YouTube link? Okay, it's up to you. As long as I can see and I can access the video, it's okay. But then I think it's a link YouTube is better, right? Because that one is not much take my storage. Okay, it depends as long as I can see the video. I can view and I can give marks to your video. Okay, all right. Okay, any other question for the lab assignment class? No. If no, then okay, you can take attendance and then you may leave.
We switch to this. Is this okay? We switched it. So the slides are gone and it